Okay, so this video is going out by request, and I don't usually do like the bare basic stuff because it's covered in a lot of different places, but I'll go ahead and do this as a favor to the ham community and to anybody else who wants to check it out. And this just kind of a primer on like what is desktop 3D printing and how do you get into it and how do all the little thingies go in and out, what's the workflow, that type of thing. And if you don't want to watch straight through or you want to watch something again, I always put time indexes in the video description so you can just click on the time next to the description and it'll take you that section in the video. And speaking of those sections, here they are so that you know what you're getting into. First, let's talk about what 3D printing actually is, specifically desktop style 3D printing like you would do at home. So at its core, it's just a type of additive CNC manufacturing. If you think CNC, usually it'll conjure up visions of big computer-guided mills, removing large quantities of material from blocks of some kind of medium metal or plastic or whatever. Additive manufacturing, on the other hand, builds up that material rather than taking it away. And there are three major categories of this type of manufacturing that are commonly used. There are others, but this will get us started. SLA is stereolithography. That's where you just have a vat of photopolymer resin that's developed into some kind of positive solid object by a laser. SLS works kind of a similar way, except instead of a large vat of liquid resin, it's a large container of powder. And then FDM is fused deposition modeling, where you just take molten thermoplastic and layer it one layer on top of another, building up the shape. And that's what we're going to focus on, FDM, because that's really what we're thinking of when we think of like home desktop 3D printing. So additive manufacturing has been around for a long time, but the desktop home DIY type of industry started out with these two grinning guys with the RepRap project, where they were like, hey man, what if we made robots that built themselves? And these fellows didn't take their work and sit on it. No, they open sourced everything. So that brings us back to the community. You'll find that the 3D printing community is very much geared toward open source and very suspicious of anything that's not open source. So you hear a lot of terms thrown around like Creative Commons and GPL, a lot of Linux talk, etc., etc. But basically, the tech was sat on for decades by a couple companies who didn't do a whole lot with it, and then as soon as it was opened up to the community at large, it's developed leaps and bounds just in the last decade and a half or so. So where do you find things to print? Well, there's a few options there. Obviously, you can make the 3D models to print, and we'll talk about that in a little bit. But to demonstrate how you can find 3D models that are ready-made and print them, we'll use the genesis of this video as an example. It all started with this gizmo, which is a on button for a subcarrier wave for ham radio, I think, something like that. I only briefly looked at the website, but I was asked if I could go ahead and print out an enclosure for it that was posted by David James at the site Thingiverse. And Thingiverse is a site where people just kind of post and trade like 3D models. It's technically called like a 3D marketplace, and there are others like My Mini Factory and Pinshape and GrabCAD, etc., etc. And all those various sites and various creators have different rules under the models and under the site headings and the user agreements and that type of thing as to what you're allowed to use the models for, as in like commercial use, not commercial use, if you're supposed to be able to remix it or if you have to use it as is, and how you're supposed to credit the original creator. Well, that's great and all, but how do I get a 3D picture into my printer? So let's talk about the workflow, starting a project and walking through to a 3D printed object. Basically, when you begin, you're going to create your 3D model in CAD, any CAD, computer-aided design. You're going to export the surface of that three-dimensional model as an STL file, and you're going to import that into a slicer, which just, well, slices it into layers along the Z-plane, and then it converts that into moves for your printer. That's in the format of G-code, which is just a human-readable text file full of directions to the printer. So let's take Mr. James's file, for example. He went ahead and designed this container for this particular gizmo and then uploaded it to Thingiverse for other people to use. You can then download that as an archive and unzip it on your computer. Inside, you'll find a bunch of mumbo jumbo and various files, but these are the two that you would be interested in. You can identify them by the file extension .stl. Which, as you can see in this Wikipedia diagram, is just a triangulified, not triangulated, that's completely wrong. Anyway, it uses triangles to represent just the surface of the three-dimensional object that's then translated to your slicer, which is a program that holds all the different parameters of your particular 3D printer, as well as a whole bunch of different options that you can use to, well, slice and dice it the way that you'd like it. That's where you pick how many walls you have, how dense your infill is, and that type of thing. There are a lot of slicers on the market, but the most popular are Cura and Slicer. There's also KISS Slicer, Prusa Slicer, Ice SL, and Simplify 3D, which is a paid slicing program. But most people these days are using some version or derivative of Cura or Slicer. Also, you should know, a little inside baseball here, it's fine to call Slicer Slick3R or Slick3R, because having a program in the category of slicers named Slicer is just confusing, especially since there are programs that are not slicers that are also called Slicer. So this man took it upon himself to get the community calling it Slick3R. And that's a name that you should know, Thomas Salomon. Check out his channel as well. Now, I won't go into the specifics of these slicing programs, but basically this is what it lets you do. Visualizes the layers as they're being drawn and lets you select various options and then try them out and view them in 3 dimensions in the window. This is, of course, as you can see in the upper left-hand corner, the Cura slicer. This is Slick3R right here, noted by its refusal to change from an orthogonal to 3-dimensional view and its propensity for hiding your 3-dimensional interface when you want to change any parameters, but I digress. After you've sliced your STL into G-code, you need to get it into your printer somehow. You can either do that by transferring it with these little SD cards, which is on about 90% of printers, or if you want to get fancy schmancy, you can network your printer and just set up a 3D printer server. Usually we use Octoprint, which is a lovely program made by Gina, and I won't even try to pronounce her last name. But it'll let you remotely control your 3D printer just like you would do with just a regular old 2-dimensional desktop printer. Then your funny little Cartesian robot will just melt the plastic and lay it one layer on top of another until it's the shape you're looking for. But what are we melting, I hear you ask? Well, we call it filament. It's just a spool of a particular diameter of plastic, and there are certain formulations that we use. Generally, anything that has a low-ish melting temperature is fine, but they all have particular physical characteristics after they have been printed that make them more or less conducive to certain things. Do you want it more rigid? Do you want it more flexible? Do you need it to not shrink? That type of thing. Far and away the most popular is PLA because it's the cheapest, it's derived from natural materials, it's starch-based, it's biodegradable, and it's compostable. It's also very, very easy to print. ABS is also popular as well, so is PETG and nylon, as well as other formulations of filament. There are lots of hybrids like carbon fiber chop inside PLA. You can even get like brass particle filled, but those are all things that you'll learn along the way. If you start off with PLA, you pretty much can't go wrong. So what if you have no printer and you need a part? Well, there's 2 options. One is obvious, but the other is you can go to online printing services if you need a particular part done or if you need it done on some kind of fancy machine. Those are basically called print hubs or print hub marketplaces, and they're either businesses who have 3D printers and will print that for you and send it to you in the mail, or there's others who just network home users who would like to use their printers to print your part out for a small fee and then send it to you. There may even be maker spaces or hacker spaces in your area that have 3D printers that you can avail yourself of. But if you're going to be serious about this, just go ahead and buy a printer. They're not that big a deal these days. They're easy to assemble, easy to work, and really cheap. So if you're brand new, you might just be thinking, well, what printer? I have no idea what any of these are and how many money units does it cost? Well, I'm happy to say that these days for around 200, maybe 300 bucks, you can get into a very basic functional printer. For example, all the prints I'll be showing you in this video, I ran off on a sub $200 printer. But of course, where there is a thing, an industry will arise to get more money out of you for the thing. So you can spend anywhere from a couple hundred to a couple tens of thousands, depending on what you're looking for. So let me show you a couple examples of different categories and price points just so you can get an idea what's going on. Starting at the expensive end, if you want something that's like fancy schmancy and elegant and well supported, has a good software to back it up, well, you might go with something like the Ultimaker. They're popular in like office environments because they're fully enclosed and can just kind of sit out in the corner. Everything works well out of the box. If you're looking for something that's a little bit larger and more rough and rugged, you could grab something like a Lulzbot Taz, which are well known for their durability and their support. Speaking of support, it's tough to go wrong with something like a Prusa i3, which is a great all-around printer. Software integration and support is amazing, and the community is incredibly helpful. It's also very well tuned out of the box and very simple to get good-looking prints right off the bat. And if $750 is a bit much, Prusa recently put out a mini version which should print as well as the others, but it's just not quite as large a print volume. And then if you're looking for the best budget printer or the best entry printer or the best first printer, I'd still have to say it's the Creality Ender 3, which I happen to be doing a video series on modifying right now. It prints great out of the box, and it's a good enthusiast platform where it's very moddable and convertible to different needs if you may need those in the future. So it's a good choice if you're just looking for the cheapest printer you can find that's going to work and not burn your house down, or if you look at something that you can tinker with and grow with in the future. But again, they're the other ones I mentioned if you don't want to tinker. And there are many choices, hundreds on the market in different shapes and sizes and styles and kinematic platforms that I won't even get to in this video. And as with any printer, your main consumable is going to be your filament, which is about $15 or so for 2.2 pounds. Sometimes you could find budget filament cheaper. You can buy fancy filament with sparkles and glow in the dark for much more if you so choose. As far as where to buy them, there's a lot of options too. I mean, they do have a basic assortment at like local Micro Center if you're in the US and, well, live near a Micro Center. You can also buy from online 3D printer specific stores like Matter Hackers, which is a very popular one, or directly from the manufacturers. They usually sell direct to public like psha3d.com. Or you can check out any one of a number of storefronts for these particular brands like Creality 3D on places like Amazon. If you want to save a couple bucks and you don't mind living on the edge, you can also go with large middlemen who import these from overseas and resell them to the public. Popular sites along those lines are GearBest and Banggood. Or you can just skip the middleman altogether and order directly from Shenzhen. Usually you can get it at a pretty good deal, and they have some sales coming up as well. Just bear in mind that with any of the overseas sellers or middle persons, it could take 4 or 6 weeks for it to get here because it has to come on a slow boat from China. Now, my wife would beat me about the head and ears if I didn't have some kind of commercialism in here. So if you think, hey, I'm going to go ahead and order one of these from Amazon, check out the video description. I have a click-through link where whatever you purchase after clicking that, they'll give me a percentage of it. Thanks. But speaking of angry spouses, I'm about to get you in a lot of trouble because AliExpress has all kinds of things you didn't know you needed. For example, VHF connectors, VHF to radio frequency to BNC connectors for pennies a piece, wire and solders and soldering irons and anything your heart desires. Just be aware that sometimes the descriptions are a little wonky, like for example, this is not a frequency counter, this is a low noise amplifier. But I guess it could be a low noise amplifier for a frequency counter. Who am I to judge? Here's a little bonus primer on some CAD stuff. Feel free to skip this in the time index in the video description if you're not interested. But we are not in the age of $10,000 per year per seat CADs anymore. There are tons of free CADs out there. An example of some of the more popular ones, there's Tinkercad, which is just an in-browser CAD that anyone can use from any machine anywhere in the world. It's very simplistic and geared toward youngins, but it's not bad for knocking things out if you don't have access to your terminal. Another popular one is SketchUp, which isn't exactly a CAD, but it can export as STL files, and most of the time they're printable, but sometimes they need a little bit of repair. By far the most popular CAD is Fusion 360 these days among makers because they have free makers licenses, which you have to renew once a year, but they haven't started charging for it, so that's good. There's a steep learning curve, but it's not as bad as it used to be back in the day. And then there are also commercial options like Rhino or SolidWorks, etc., etc. Typically, I'll use some combination of like Fusion 360, 123D Design, OpenSCAD, FreeCAD, MeshLab, MeshMixture, and Blender. It really depends what I'm doing and how I'm trying to do it. Personally, I think the best balance of learnability and usability is Autodesk's 123D Design, but unfortunately it's been discontinued and you can't get it anymore. But if you can find, beg, or borrow a copy, it's a good place to start. And if I ever meet an executive from AutoCAD, I will scream in their face like a baby eagle until they put a usable, historyless direct solid modeling mode into Fusion 360. I know they kind of have one, but I said usable. Because it's so nice for simply and quickly knocking out simple things like, project boxes and things that will be useful. So you might be thinking, okay, but what am I going to do with this 3D printer, man? I don't just want to get a printer and have a printer as a hobby. Well, that's the thing. It can be a hobby in and of itself, but it's more like a gateway drug to a bunch of hobbies. Or if you're ambitious, a bunch of business ventures. For example, I first got a 3D printer just because I wanted to make custom bobbins and coil forms for inductors. That made me think, hey, I'm not just relegated to making bobbins and coils, I can make coil winders with this thing. And I thought, why stop there? I'll just print a couple more printers with this thing. And before you know it, I was making vases and dimensional tests and oscilloscope shrouds and spool holders and all kinds of brackets and whatever this thing is. For example, radio guys, what if you're someone who likes to ham it up, pun intended? Well, in addition to obvious things like project boxes, you could also make mounts for your antennas, you can make faceplates, you can make hangers for your CBs, Morse keys, ground antenna tie downs, etc., etc., etc. Or parts for model ships or whole model ships or wargaming minis or railroad features, soap making molds, stamping, whatever will take up space and annoy your spouse. Just looking around the workshop, these are like the first 15 things I saw that were 3D printed, like prototypes, jigs for checking for fit, rigs and jigs, fasteners and brackets, routing templates, stencils, containers and organizers, custom tools, like let's say you needed something that held a razor blade at exactly 60 degrees, you can go ahead and print that, radiusing blocks, man, spherical radiusing blocks, third, fourth, fifth hand clamps, coil forms, guitar picks, equipment mounts, knobs, faceplates. You can print out custom lathe chucks like David Reed Smith here. And speaking of woodworking, you can fill it, seal it, sand it, and finish it just like you can wood. It just takes a little bit different technique. One of the reasons that people still print in ABS is that you can use things like acetone to smooth it out to like a nice glossy shine. But again, if you're used to woodworking, there's no reason you can't take other types of materials and finish them as much as you like as well. You can check out sites like Rigid Ink has some demonstrations, GameBody has some demonstrations. For example, here's the little project box that I made. So I took this and went ahead and sanded it down and then just put some heavy-bodied sealer on that, sanded that down and sprayed a little bit of shellac on top of it. Put just some regular old black rattle can spray on top of that, waited for it to dry, sanded that down a little bit more, and then used some clear coat on top to give it a nice textured finish. But I've rambled long enough and I'm going to end this video before I hit the 20-minute mark. I work with more of like the uber nerdy stuff and the modifications and that type of thing on this channel, but here are a few other channels you might want to check out if you want to see if 3D printing is for you. But feel free to subscribe to the channel here, especially if you plan on grabbing an Ender, because I'm doing an entire series on that, and check out my support links in the video description below. Thanks a lot, and until the next video, get out there and make something awesome.